Triangle networks are being studied as quantum systems that don't have any input. My bold claim is that one can construct a consciousness model based on those and based on an idea of a theory of everything, physically tantamount to simplex structure. So the starting point is to create a system from scratch and beginning simply with a point. Here it is shown as a blue one, and we assign to it an ordinal number 1. The next one, the red, is positioned at unity distance, and so we define a connective measure of unity between subsequent points. And adding the third point, green one, we create a triangle. And this triangle is created because we also add this additional stringent condition in n-dimensional geometry, so that every point is also connected by unity and distance to all other points. So there are two distance measures. There's one-dimensional succession and n-dimensional unity distance to create n-dimensional geometry. So we first have a point, then line segment, triangle, tetrahedron, and we can see also that in this idea, adding vertices is what makes time pass. So every added point is a vertex of an n-simplex, and it's positioned at the same n distance to all preceding points, and in this case the n distance is unity. And if we think that the points are not ordered, the addition a new vertex produces equivalent n-dimensional structures. Instead, when we apply ordering, we have, once we get to the triangle, we have the points of the triangle are ordered, then we can decide a convention for left and right. And it is depicted here through this black line that is giving the ordering, and you can see that there is a difference in this way of seeing either left-handed or right-handed system. This is the path that is different. It is not equivalent anymore. But from the perspective of the one-dimensional measure of distance, we are getting the same distance from blue point to the yellowish one. Why this is important? Well, triangle networks are under study, especially here in University of Geneva, and they don't have any inputs. And the bold claim is here that this triangle in itself creates a system that then collects the outcome of a measurement or outcome of a decision, however we wish to call it, into a fourth point. That is the in earlier pictures it was the yellow one, and this binary outcome is either right or left, and it creates new structure of the system. So what we can find is that the structure in itself is growing and registering the outcomes of these measurements or decisions. And the boldest way to look at this is to say that the triangle is already conscious at some elementary level and makes the decisions to go either to the left or to the right. And what is interesting also is that when we have these various points added, there is the barycenter that is moving around. So when we add the red second point, there's displacement of 1/2. And when we add the third point, there's displacement of 1/3, and so on. So when we form a tetrahedron, displacement is 1/4. And this is noteworthy that it's the same displacement independently of whether we decide to put the yellow vertex to the left or to the right in respect to the existing triangle. So this is invariant in that sense. And why these figures here, 1/2, 1/3, and 1/4, and so on, are important is because they are the coefficients in logarithmic series expansion, and we have possibilities thanks to the distance measure that's one-dimensional to make some fixes to this presentation, and we can obtain a logarithmic function, and this is the basis to the logarithm pole model that I'm working on. And in logarithm pole model, we have the n-dimensional simplicial structure where the movements of the barycenter create the kinematics, since the every vertex is kind of displaced each time a new vertex is added to the system, and also we get this logarithmic poles instead of just one countable point. We can differentiate alternating positive and negative poles, and when vertices are added to the system, we are closing in on the values we are obtaining from the logarithmic function. Initially, we are having only some terms, so it is not very close to the logarithm in the very beginning of the system development. So that's all for now.